Aircraft materials, processes, and hardwares, properties and types of metals. We're going to identify the 11 properties of metals used in aircraft maintenance, and then we're going to differentiate between the ferrous and non-ferrous metals. Properties of metals. There are 11 properties of metals primarily concerned with aircraft maintenance. We're going to start off with hardness. Hardness is the ability of a material to resist abrasion, penetration, or cutting. It can be increased by cold working or heat treating. It can also be used for steel and certain aluminums. Strength. Strength resists stress and deformation without breaking. Density is a specific weight of a metal per cubic inch. Malleability allows the material to be rolled or pressed or shaped, whereas ductility gives it the ability to be drawn or bent or twisted. The property of elasticity deals with external forces. When they're removed from a material, it returns to its original shape and size. However, if you exceed the elastic limit, when you remove the external force, you will notice a permanent distortion, kind of like a balloon when you blow it up. It's fine until you blow it up to a certain point, and then when you release the air, it never comes back to its original shape and size. Toughness, on the other hand, is going to resist tearing or shearing. It may be stretched or deformed without breaking. Brittleness, on the other hand, allows for little deformation without shattering, kind of like a piece of glass. Fusibility is the ability to become a liquid and to be fused together. Steel is going to melt at 2600 degrees Fahrenheit, whereas aluminum melts at 1100 degrees Fahrenheit. So there's no way that you could fuse steel and aluminum together. Conductivity property is the ability to carry heat or electricity. Copper is a good conductor. Aluminum is almost a good conductor. Not only do they carry electrons, but they also transfer heat readily. Thermal expansion is a contraction or expansion of a material, typically based on the heat. They're going to expand and contract at different rates depending on the material they're made out of. Base metals such as iron are often combined with other materials to improve the chemical and physical properties. These metals are called alloys. Two kinds of alloys are ferrous, which is iron-based, and non-ferrous. Ferrous aircraft metals has iron as its principal constituent. We're going to add ingredients to iron to become one material, and this is going to change the strength of the iron. Ferrous alloys are going to include things like carbon steel, nickel, chromium. Carbon up to 1% is added to produce a vastly superior material than iron alone. It's going to allow for increased strength. When small quantities of other elements are added to the base material, it is also called an alloy. They're identified through 4 or 5 numerous systems. The SAE, or Society of Automotive Engineers, and American Iron and Steel Institute, AISI, they have a numerical index. These numerical indexes are going to tell you exactly what the alloys are. Not important to remember the numbers as it is to know where to research them and find out what material you're working with. Each number is going to indicate the type of the various alloys you'll be working with. Non-ferrous metals do not contain iron as its chief constituent. They include things like aluminum, titanium, copper, magnesium, Monel, and Babbitt. Non-ferrous metals have a 4-numeral system indicating the type of metal used and can be followed by a classification to a type of heat treatment. Aluminum is one of the most widely used materials in modern aircraft construction. Commercially pure aluminum has a tensile strength of about 13 ksi, which in the big scheme of things is not very strong. By adding alloys and adding heat treatment, we can increase the tensile strength up to 65,000 ksi. We're going to divide the aluminum into 2 general categories, castings and wrought. Casting is poured and wrought is worked. Aluminum and its alloys. Pure, commercially pure aluminum is a white, lustrous metal, 6th in ductility, 2nd in malleability. It is also high in its ability to resist corrosion. Commercially pure aluminum has a tensile strength of about 13 KSI, but can be almost doubled by cold working alone. So you could raise that 13,000 KSI to 26,000 KSI just by cold working the aluminum. Once it's alloyed, it's going to increase its strength, but it's typically still easy to work. Castings can be divided into two groups: physical properties that cannot be changed once casted, and heat treated to achieve desired physical properties. Wrought, on the other hand, is the most commonly used. Wrought aluminum is divided into two categories: heat treatable and non-heat treatable. Wrought aluminum is designated by a 4-digit code. Group, if you look on the right there, you have 1, 2, 3, 4. Those numbers are going to indicate the chief alloying agent. So 1, XXXX, would be pure aluminum, whereas if it starts with a 2, copper would be your chief alloying agent. A 3, manganese would be, and so on all the way down the line. So you can tell by the part number of an aluminum object what the chief alloying agent is, which is going to lead you to the ability to tell what strength it's going to have. Wrought aluminum is designated by a 4-digit code. When referring to the 1, telling me it's pure aluminum, the last 2 digits indicate the percentage above 99% that your aluminum is actually pure. So an 1100 wrought aluminum would be 99% pure. 1130 would be 99.3, and 1175 would be 99.75% pure. Once we add the alloying agents, the first number, 2 through 8, indicate the major alloying element. The second digit indicates the number of alloy modifications, and the third and fourth indicate the different alloys used in the group. So 2117, the 2 shows that copper is the major alloying agent, the 1 indicates the number of modifications, and the 17 is going to tell us the different alloys in that group. The hardness identification is followed by the alloy. So 2024 T3, the 2 tells me that, again, copper is the major alloying agent. The 0 is there was no controls. The 24 is the group of alloying agents to make up that material. And the T3 tells me that it has been heat treated. Temper designations for non-ferrous aircraft metals. The F is as fabricated. The O tells me it's annealed or softened, whereas the H is strain hardened. The H can be strain hardened and then have additional codes H1, H2, H3 telling me strain hardened only, strain hardened and partially annealed, or strain hardened and stabilized. The W is an unstable condition, and the T indicates that the material has been solution heat treated. Magnesium and magnesium alloys, the world's lightest structural material, especially when alloyed with zinc, aluminum, and manganese. Large aircraft have hundreds of vital spots that use magnesium because of its high strength and low weight characteristics. One of the drawbacks to magnesium is its high fire hazard. It requires a special fire extinguisher, a Class D fire extinguisher. If you spray water on a magnesium fire, it's only going to intensify. Magnesium's another drawback is the fact that it's very active. It corrodes extremely easy. Titanium and its alloys, when used for corrosion attack, are going to be used where corrosion attacks are prevalent. Titanium has a high resistance to corrosion and is often used for engine firewalls. Titanium has different designations, has an A alpha, a B beta, and a C alpha beta combination. Copper and copper alloys has high electrical and heat conductivity. We're going to see a lot of copper used in aircraft electrical systems, especially the smaller electrical wires. Brass, which is a copper alloy, contains zinc with small amounts of aluminum and iron, lead, manganese, and magnesium. Bronze, on the other hand, is a copper alloy containing tin. Monel is a nickel alloy that combines the properties of high strength and corrosion resistance. K-Monel contains mainly nickel and copper and aluminum. Nickel and nickel alloys. 2 nickel alloys used in aircraft are Monel and Inconel. Both have high strength and toughness characteristics. This slide needs to be deleted. We're not going to talk about substitution of metals. There are 11 properties of metals of primary concern for aircraft maintenance technicians. There are two types of metals, ferrous and non-ferrous. Ferrous metals have iron as their chief constituent. Carbon can be added to increase the strength of ferrous metals. Aluminum, its pure strength, has low strength but is highly resistant to corrosion. When alloyed with other ingredients, we can increase the strength of the aluminum. Some alloys can be heat treated to again increase the strength higher. Magnesium, when alloyed, has the highest strength to weight ratio of any commonly used aircraft metal, but it is extremely active, meaning that it will corrode very easily, and it is also flammable.